blood, sweat, and tears. You bleed passion. You want to take your game to the next level. You want to learn the National Electrical Code. Maybe you have dreams, desires, hopes. Maybe you want a better future for your family. Maybe you're tired of just pulling wire all day and you want to be the leader, the supervisor, the owner. You can reach those goals if you're dedicated to it. That's why we're here. We want to give you the guidance, the direction. You can achieve all those things. Let's do it. Are you ready? I know you are. Being a master of the code is no easy task. Learning the NEC is a huge hurdle that you must pass. Staying focused on the goals is easier said than done. Studying with a passion is how it's usually won. There's no room for lazy, unfocused hum. Not knowing the NEC is like being mentally numb. Learn the code is a true worthwhile passion. Ignoring your haters who seek to throw trash on. Follow your dreams are like prepaid tolls. You have to put in the effort to reach those lofty goals. I can say it's abundantly clear. Listen and learn to me and you will truly learn the NEC. Yeah. Master the NEC. What up, everybody? Welcome to another live stream here in Master the NEC. My name is Paul Abernathy, and if you don't know who I am, welcome to the stream. I'm just a fat little bald guy who likes to teach the National Electrical Code. Haters are going to hate. It's all good. I like to teach the code, and whoa, new subscriber. Thank you. So, welcome to the stream. I want to thank everybody. Little different intro. Sorry about that. Look, I got all kinds of new subscribers jumping in. Thank you for joining the channel and sharing it with everybody. So we're excited about what's coming up in the new year. And with the good, there is the bad. The bad being, this is the last public chat that we'll do for the exam prep. But again, there are ways that you can get the exam prep as we move into the 2021. And so again, we'll talk about that later on as we get further into tonight's lesson. Okay, so again, if you hear my dog tonight, apologize for that. My dog is loud and I can't really, man, we got a lot of subscribers popping on the screen. So let's see here. Let's see. Some of the times the chats, there we go, it's back again. Sometimes it can be really buggy when it comes to these live streams. So again, with me, Mandingo, thanks for joining me tonight. Nick, Scott, I know you're out there for subscribing. Thank you for subscribing. Moise, thank you for coming. Mike, thank you. Merry Christmas to you. Happy New Year to you and your family, everybody. Thank you for joining me. And I know I'm probably missing somebody in the stream. Hold on for a second. So it's my dog. Sorry. I said, shut up. All right. So again, Merry Christmas to everybody that joined us in the stream. Hopefully you'll get something out of tonight. We got some questions. Hopefully we'll look at them and kind of dissect them. Hopefully you got your code book handy. Before I get into that, I will remind, boy, the subscribers are just popping up on the screen. Before I get into that, I will remind you that over on this YouTube channel that you're watching, you can subscribe to the paid version and you can get all of the exclusive content, the entire series on swimming pools and spas and hot tubs. You can get that, as well as we've worked our way all the way up to Article 225, and we're getting ready to work in 225. So just a little bit more in depth. In 2021, I'll be offering a whole lot of additional content for subscribers. And I'm not meaning subscribers to the channel, but I mean the folks that actually do the monthly subscription thing, because that's the method we're going, and those people don't have to worry about commercials and the ads and all that kind of stuff. That's kind of where we're going in 2021 for that. But of course, I always still put out content. My podcasts will be the same way they always are. So if you like the podcast, they'll be the same. Nothing changes with the podcasts, things like that. So anyway, let's spend the time doing exam prep. So hopefully you got your code books, your 2020 editions. of the National Electrical Code. Hopefully you got it. If you got the 2017, that's okay. Not a big deal, because we'll we'll look at that too if it's needs to be a 2017. But at any rate, again, Merry Christmas to everybody. Hopefully everybody's had a good holiday. I'm personally don't care much for this holiday so far, but that's just me for personal reasons. But hopefully all of you have a wonderful holiday and have a prosperous 2021. And let's put this COVID thing behind us, right? That's what I'm talking about. All right, so let's go on and get started. Hopefully you got your code books out. You've got your calculators, if necessary, out. You've got your scratch paper out. Everything's out. And we'll go on and try to get into some code here. Okay, so we got some code. And let me see if I can get this chat to refresh. There we go. Hey, Eric, Merry Christmas. And thanks for joining me. All right, so on the screen, folks, you see a code question. We're going to go through these code questions. We're going to talk about dissecting it a little bit. If you're new to this channel, what we do is we don't just give you the answer. We try to dissect it and find where in the code we're finding this information. And I'll give you little tidbits of things to remember, maybe tips about a certain question or something like that. There's a lot of things when you go to take an exam. There's a lot of things that you really just need to know, because you're going to run out of time on the exam if you don't know certain things. So some of these things will be things that I'll call out as things that you should just know. Try to commit to memory and things like that. So we'll kind of got to do that as we go through some of these questions. And you might have noticed there's a little different layout than usual. Hopefully you like it. But it's a little bit different. We're spicing things up for next year. Hey, Jay, welcome to the show. Jay's my co-host on Electrician Live, and we're going to spice the look of Electrician Live up for the new year as well. So ought to be going to be great as normal. So we're going to try to kick it up a notch, if you will. So let's get started. So you see the code question on the screen. So if you're new to the channel, this is what we do. I'll present a code question. I'll give you time to look it up. Now, why do I do this? Because a lot of people watch these later, and it gives them time to pause the screen while they go look up the question and then come back. And of course, if we time out or anything, then I'll reset it and we'll just go from there. Okay. And Trey, I don't know if I'm saying the name right. Trey's already given us an answer. Everybody else. And here's what I usually say. Look at the question. Don't look at the chat, so that you don't get, persuaded by anybody else's post. But the best way you're going to get something out of this is if you just listen to me and then open your code book and look it up yourself and then look at the chat. Don't look at the chat until after you've looked up a question, okay? Kind of setting the tone in the code, and we'll look everything, and we'll kind of look everything up. Hopefully I got everything queued up to work fine. So this one is a metal underground water pipe may serve as a grounding electrode where it is in direct contact with the earth for at least blank feet or more. So if you're preparing for an exam, some of the triggers here is obviously we're talking about a grounding electrode. So if we're talking about a grounding electrode, you know already that you're going to be a certain area of the National Electrical Code. Okay, so the first thing you should know, we're talking about electrodes. So one of the things you could do is you can go to the index and you can look under electrodes, grounding electrodes. Those are terms you might want to look under. You might go in the back and look under metal underground water pipe. Those are things we call triggers or key terms, okay, back in the code. And we'll do that as we go through when they're a little more difficult. But again, we've got a lot of correct answers that are on the screen. So again, I'm feeling that this one is not so difficult, okay, as we start out. So the key thing is, remember, we're talking about grounding electrodes. So if we were to go to the code, and I'm going to do this because I want to make sure that's working and everything before we get too deep into this. I'll go to the NEC. And I don't like meters. Don't give me anything in meters tonight, guys. I don't want anything in meters. We want the feet, inches, things like that, not meters and things like that. I'm just not. You're not going to get a code question on meters. The code questions are going to be in feet and inches and things like that. So now we don't have the index is not an option in my electronic version, which is why I don't use the electronic version. When I'm teaching a class, I teach this. So if I was going to do like you and get your code book and go open your code book and go to the index. What you want to do is you want to get extremely familiar with the index, right? Get really familiar with whipping through the index and looking at things. But I might go in the index and I might look under, just so I can look under it, and I might look under and see, well, we have electrodes. Okay, I see electrodes. Under electrodes, I see metal water piping. Okay, so electrodes is what we're looking for. That's the trigger of the term. We saw the term grounding electrode. We know that there's a bunch of different types of electrode. Water pipe electrode, in-ground metal. We've got rings, we got plates, we got rods, we got pipes. Okay, we got other types. We got existing things like tanks, metal tanks that might already be on the premise. So we have a bunch of different things under 250.52. And there's a list, A1, A2, A3, A4, A5, A6, A7. So we're dealing with the water pipe ground. So under the index, under electrode, I would have seen metal water pipe, which is what's in the question. Another thing that I might do, and really the reason I'm doing this on the first one, so I don't have to do this every time, is showing you how to find key triggers if you didn't know. Okay, the other thing would go to M and see if there's anything under metal water pipe ground. So I'm looking under metal, and I'm looking and seeing if there's anything about metal water pipe, just to see. And I don't see anything under metal water pipe. That would be very broad, probably not something too specific to the electrodes. Electrodes the trigger, okay, grounding electrodes. And let's see if I also went under G for grounding electrodes. And bear with me as we kind of get started into this. I want to make sure we show people what we do. So we go to the code book, and we're going to go look under grounding and see if we see something that says grounding electrodes. Okay, see grounding conductors, grounding electrodes. It says C electrodes. So we were right there when we picked electrodes. So that's how we use the index. All right, so when I say that, what I want to do is I want to come back to me here. So what I tell people all the time is, as you're studying for the NEC, make sure that you utilize, during your study time, make sure you utilize the index a lot. Okay, so another tip I can tell you is, if you get a hold of a good set of questions and you get those questions, I want you to spend, in your study phase now, when you're studying, I want you to spend at least 5 minutes on each question. Not to answer it, okay? Not to answer it, but to dissect it. So when you first go through it, for example, we looked under metal underground water pipe. There was nothing there. We looked under electrode. That's where we found it. We looked under grounding electrode. It sent us to electrode. Those are triggers. And I just want you to get used, and I figured I'd do it on this first one. As you're studying the code, now when you're preparing and you're doing the practice stuff like the guys do in the Fast Tracks program, then you can start timing yourself, putting a 2-minute timer and try to find things. People ask why we don't time every quiz or every practice exam, because every state's different. One state might, if you break the number of questions down, they might be 3 minutes a question. Texas, it might be 2 minutes a question. So it's so much easier just to put a timer on your phone and take the question, set the timer, hit 2 minutes on the timer, and answer this question. And that's what we prefer you to do, okay? All right, so a lot of answers, all great answers. So let's go on and answer the question. Everybody seems a consensus. It's 10. And that would be correct. 250.52A1. Now you will notice, hey Tim, I didn't see you in there, buddy. Welcome. So what you'll notice is, in this case, there was no change. It didn't matter whether you're in the 17 code or the 2020 code. It really didn't make a difference here. My point with this first one was to make sure that you get into a practice for all you new people. Make sure you get into a practice of, hold on for a second, I'm thirsty. I have no idea what that is. Make sure you get into a practice of dissecting the question, because it'll only make you better. Then you can worry about timing yourself later. But when you start learning the code and you're preparing for an exam, dissect those questions, because it forces you to go to the index. Okay? It forces you to go to the index because that's where you get better. Because you learn what you can find in the index and what you can't find in the index. Because the index is not the holy grail, as you've heard me say many a times before. All right, so let's go on to the next question. All right, so this is let's see how many people find this one. So this one, when calculating demand load for a one-family dwelling, what total minimum VA must be included in the calculation for the required small appliance and laundry circuit loads? Okay, so think about this question on an exam. It's wanting you to find the total. Now, a lot of people will react really quickly because all of these loads individually is the same VA. But on an exam, if you don't stop, so I'm giving you little tips today, not just answering the questions, but I'm telling you stuff from experience. Stop and read the question. The question has something in the question that seems subtle. It says, what total minimum volt ampere must be included in the calculation for the required small appliance and laundry circuit loads? So again, you could answer this right off the cuff, or you could stop and look at it and say, okay, I need to stop for a second because I know what the question's asking me, and I need to answer what the question's asking me. See, we already have that example right now. Okay, think about it, guys. Think about your answers. Think about your answers. You would already be going down a rabbit hole. Think about your answers. Read the question. Stop and read the question. Okay? It's important that you read the question. Now, where in the National Electrical Code does it tell you how many small appliance circuits you have to have? Where in the code does it tell you how many laundry circuits do you have to have minimally? Okay? And think about it. Think about your answers, because I'm not happy with the answers I see on the screen. And if you're not don't look at the screen. Don't look at the chat box. Look at the question. And let me read it again. When calculating the demand load for a one-family dwelling, what total minimum VA must be included in the calculation for the required small appliance and laundry circuit loads? How many small appliance circuits are we required to have minimum? How many laundry are we required to have? Okay. Very good. See, it's so easy to get the question wrong. One, because when you take an exam, you're going to be very stressed, right? Very stressed. And you got to be able to look at a question and dissect it out and understand what they're asking here. They're asking you to calculate the demand load for one family dwelling, and they want to know what the total VA is for the required small appliance and laundry circuit loads. Well, we know how many small appliances are required. 2. We know how many laundry are required. 1. How many VA are they each? Okay, we have code references for that. We have 220.52, A and B. Okay, now, if we were finding that in the code book, then we might go to where? If you didn't know, which you should know for calculations, and if you're in my Fast Tracks program, you should know this. Okay, so if we go to the code, yeah, there you go, Nick. You have to read the question. You have to know what they're asking you. And I think that's the thing that when we write exam questions all the time, that's the thing that we're doing. Hopefully I'm not overmodulated. I would ask somebody to tell me if my voice sounds okay, if I'm not crackly or overmodulated, or it's too loud, or if it's okay, because I really can't fine tune it too much. So somebody let me know it sounds okay. I know there's probably a little delay because I'm streaming over on Facebook as well. So we're on Facebook and YouTube tonight for the last of our public exam prep. That's right, Ronnie. Stop rushing. Read the question. Remember, you've got a certain amount of time, but if you read it too quickly, you'll miss out on what it's asking. And I wanted to do these questions up front so I can give you these little tips. Yes, you are. Now, let me put it to you this way. I had somebody contact me and said, I can't pass my exam and I run out of time. And my response to them was, well, let me ask you a question. Do you look up at the timer and you're running out of time, so you just start checking things? He goes, yes. I said, did you feel like you had to look up everything in the index? And he said, yes. That's a problem. Because the reason that I create, kind of have the Fast Tracks program for those that are in it is because we're giving you, obviously we can't teach you everything. Okay, we're not going to teach you how to read blueprints. You should know that because you should be qualified by this time to sit for your exams. You should know how to read a set of blueprints. I have a hard time teaching that because I don't have blueprints. But you should know how to look things up on a blueprint, find certain things on a blueprint. You should know your local rules, that if they have some kind of state rules that you have to use on an exam, they'll give you a booklet for that. But when it comes to the NEC, you want to make sure that you literally read the question so that you can answer the question fully. Okay, so again, without looking that up, this is, and first thing you should notice. Let's give me some other tips. The first thing you should notice is that this is a calculation. So firmly, it should tell you that you're in 220. The other thing that should tell you is, since I'm calculating demands, that I need to worry about part 2 in 220 because that's going to give me a lot of the values that I need. Now, if you want to know how many small appliance branch circuits you have, then that's how many branch circuits you need, then you're going to be in 210. So 210.11c is going to tell you that you need a minimum of 2 small appliances. How many laundry? Minimum of 1, unless they state otherwise, minimum of 1. Okay, so that's where you get the numbers. But in order to get the VA, you know that you got to be in 220 because it's a calculation. So when I read this question, I immediately know that I'm going to have to be in 220 to doing some calculations. Okay, so 220, 52, A and B, that was going to be the answer to that. And I don't need to go look that up because I think we all agree. So now let's see if our hunch is right. So, correct. And there's the calculation right there. 2 small appliance branch circuits, 3,000 VA, 1 laundry. The question wanted to know the total. Okay. And immediately, a couple guys put out the 1,500. And that's okay, guys. It's a good example of slow down, read the question. Okay. All right. Let's go on to the next one here. And there's your code references right there. There's that 210.11c1 and 2. That's what tells you. This is what tells you how many circuits you need, and this is what tells you what the VA is right here. Okay. Now, we'll remind you that the 2020 program, as you see, the Fast Tracks, the practice exams, they're not the best questions in the world. They're really good. I didn't write them. There's some errors in there. You'll find them, and you're going to be the people that are in the Fast Tracks program, my students are so good that they actually find these errors and they send them to me. Well, of course, I know about them already, but I love when a student finds them and sends them to me, okay? Because I didn't write the questions, but as long as even a bad question makes you think. And that's what I'm trying to make you do. Think about every question, okay? That type of thing. Subby, bruh. Oh, me. Y'all see what I got to put up with every Saturday night. All right, so let's go on to the next question. All right. Give this one a go and see what it's got. Okay, so this one, you have an underwater luminaire installed in swimming pools. Dead giveaway. A trigger is swimming pools and underwater luminaires. I mean, dead triggers there, right? And swimming pools are required to have GFCI protection if they operate at a voltage greater than blank. Okay? Now, I don't want you guessing. You save that for when you feel like you really can't find the answer. Here, take your time. Go look this up in the code. Use the index. Slowly take a question. Remember, we're not taking an exam right now, guys. You don't have to stress yourself, right? You don't have to say, oh, God, I got to answer it in 2 minutes. No. You're in the process of learning. That's what these questions are all about. Okay? Now, in our Fast Tracks program, for example, I have like 20 practice exams. You don't have to worry about timing yourself until you get to the 3 final exams. And those are 100 questions each. Then you can time yourself 2 minutes each or 3 minutes each or whatever your state has. And all you do is find out how many questions are on the exam and divide it by the time, and that'll tell you how much you have per question. And then you can time yourself with a timer. But when you're doing these practice ones, take your time. Dissect it. Use the index, because I'm going to promise you something. The more you learn what's not in the index, the better off you're going to be. Serious. The more you learn what's not in the index, the better off you're going to be. How about that? That's a philosophy for you. All right, so in this case here, we have underwater luminaire, obviously swimming pools, and trigger is, we're asking about GFCI protection. Okay, give me code references. Mendingo, you're famous for that. Give me an answer, but not give me code references. All right, so underwater luminaires. So for me, if I was using the index, say I didn't know, there you go. I knew you were typing away. It's always easy to pick on you because usually you're picking on us, right? So if I was going to dissect this and I had no idea, one of the things I would look for would be, okay, what about underwater? Now remember, I'm looking for the most obscure option first, just for me, for our lesson. And let's see, what if I were to look for underwater? And because I like to look to the most obscure option there is, and then work from there. So I looked at underwater. I'm looking for underwater, see if there's anything in there. And I don't see anything that says underwater. Okay, so I ruled that out. Okay, ruled it out. So, but what do we know we're talking about? We're talking about swimming pools. Okay, so I'm just showing you again an example of how you would use the index to get better at the code. So I'm going to dissect this and say swimming pools. So I'm going to look under swimming pools. And when I'm under swimming pools, I'll go down, and what am I looking for here? Underwater luminaires. So as I go down the indexes here, I start looking down and I see underwater luminaires. And it says 680.6, 680.23, 680.26 B4, 680.33. So my little tip for guys taking an exam, they give you scratch paper. Okay? So what I like to do on my scratch paper or your dry erase is, if I'm going to something in the index, I don't want to make 50 million trips. So what I do is I write 680 as the article, just like that. Can't see it. There you go, 680. Then underneath it, I use it and I'll jot down really quickly, okay? And I go down and I go dot 23, dot 26 B4, dot 33, dot 43 B2. And so I literally write them all down, as you can see that. but I don't need to write the 680 again. So I've already got them down. Okay. So then when I'm going to hit the code book, I only have to go and start from the lowest one and work my way up. Dot 6, dot 23, dot 26, until I find the answer. Now, people know that I teach a technique called bold scanning. Once you get to an area, you're looking for the bold scanning things that are in the question. Obviously, this question is about underwater luminaires, so we know we're going to go right to there. What we're looking for is GFCI protection and the terms that are in our answers. And we let them assist us as we're bold scanning the code text. Okay? So in this case, I'll go to the code because we know where to go. We've got some things to look for. So when you go back to your NEC, and here I am in the NEC, and I will go to 680. And I will go down to the first one, and I will remember what I'm looking for. Underwater light luminaires. I'm looking for GFCI protection and those distances. So dot 680.6 grounding and bonding. That's the basically 680.6 bonding and equipment grounding. All the terminal options, things like that, junction boxes, just kind of gives us other information. Doesn't really help me. So I'm going to the next one quickly on an exam. I go to 0.23, and that would be, if you're following along, I'm making sure you're still in my screen. We have the general, okay? And when I look at it, what I'm doing under 0.23 is I'm looking for, first of all, the question had values in it. I'm looking for these values, okay? That's what I'm looking for to see if I can find the answers to that question. GFCI protection. And here's GFCI protection. Okay. 23, we're there. It says ground fault circuit interrupter. There's the GFCI portion. For personnel shall be installed in branch circuits supplying luminaires operating at voltages greater than the low voltage contact limit. Okay. So take down, there we go. Now, some people will say while I'm there, let me look at 26 real quick to see what that might say. And they'll go down to 26, and that is equipotential bonding, and they know that it doesn't get worse. It gets worse as it goes from there, right? So we'll go back. And so at that point, we know that it's a low voltage contact limit. So that's an example where I use the answers to validate the question while we're doing bold scanning. Okay, so that's an example. I figured I would try to come up with an example tonight to explain bold scanning. So there you go. And there we go. 680.23A3. And again, 2017 reference didn't change from the 2020. So in this question, it was easy to go to swimming pools and then go and look underwater luminaires. And that will get me to where I need to be, okay? And then, of course, we're using the bold terms like the GFCI protection as a trigger, okay? And then we use the answers to help us, okay? So I'm looking, when I'm bold scanning in that area that it sends me, I'm looking for the term 50 volts, 120 volts, 15 volts. I'm looking for low contact voltage. You got to get a person that really is savvy. So you want to know the difference between somebody that's a really, really good test taker that maybe don't know the code, but they're really good at taking exams. Those are individuals who have the ability to read the question and remember some of the key terms while they're reading the code. And they automatically stick out to them and it come into their head as they're reading it. And that is bold scanning, and it takes a little practice to get used to doing that. But you can get it, and you can get good at it, because you want to use the answers, because all exams are going to be multiple choice. So you want to use the answers to help validate the question, to validate the triggers that you're using to find the answer. And when I tell you about examining a question, that's the reason why I want you to use the index and back and forth, and use this little tip when you're doing dry erase board. Write them all down. That gets you where you need to be, okay, to answer the question. All right. So let's go on and go to the next one. All right. see how you do on this one. Any cord and plug connected portable appliance connected to a 120 volt, 20 ampere rated branch circuit shall have a maximum rating of blank amperes. Okay. So I want to know, don't just give me the answer. Tell me where you find it. Where is it at? And then we'll dissect. Now, the first thing I'll tell you, you know right off the bat that it's asking about a branch circuit. So it's talking about cord and plug connected portable appliances connected to a 120 volt, 20 ampere rated branch circuit. Okay, so we have to find the answers for this. So give it a look. See, I'm going to do it as well, and then we'll dissect it and see where we might find the answer. Now, for some of you, you're very savvy in the code. I know you are. You've been doing this for years, so you can look at this and you already intuitively are thinking, oh, I know where that is because of certain terminologies in there. Okay, things like that. They're like, oh, I know where I need to be, and things like that. So that's where you go, and you're thinking, boom, I'm going to go to it. I think Mike Sparky, it might be on a slight delay on yours. It might be a little bit of a delay. So I'm going to go where I think it is in the code book, and y'all follow along and see what you think. We have different here. So what we're looking for is the maximum rating in amperes that we can have for one cord and plug connected portable appliance connected to a 120 volt, 20 ampere rated branch circuit has a maximum rating of blank amperes. Now this would be the branch circuit. Okay, so it's a 20 amp circuit, but we're going to looking for what the maximum rating is for one cord and plug connected portable appliance. It's going to actually plug into the receptacle. Okay. And I like what I'm seeing, so let's everybody make sure you give code references. The bala, I can't even pronounce what that is. The balajaba. Sorry, brother. It's the best I got. Okay. I'm feeling code strong. I'm feeling some code strong going on. Okay. I'm feeling some code strong in the house. So I will say, I'm going to give you guys a little bit, and while I'm talking, you look it up. Don't look at the chat, folks. Look at the question. Remember, the appliance is just there to throw you. It doesn't care. You're plugging it into a cord and plug is obviously going to be plugged into a receptacle. Okay? So, and some people get cocky when they are in their chapter 5 of their residential program. They get cocky and start getting additional information and things like that. So anyway, so one cord and plug connected portable appliance. Okay. It could actually be a garbage disposal that is cord and plug connected into a receptacle underneath the counter. That would be an example of cord and plug connected appliance. But it is a 120 volt, 20 ampere rated branch circuit, shall have a maximum rating of blank amperes. Okay. And I'm just kind of letting some people go, but I think we have some pretty good answers so far. There you go, Nick. There you go. All right. So where is that in the code? Let's go to the code book. All right. So we're over in the code book here. I'm going to go back to the top. Oh, and if anybody's asking me what code book I'm using the online edition. I'm not going to lie to you. Because I serve on code making panels, I have access to every NFPA standard. As you know, again, that's the least they could do with the amount of time that we commit to helping develop the NEC. So I appreciate NFPA for that electronic version. Much appreciated. But I've got access to all the codes, and I wanted to announce, and I hasn't announced it yet, but in 2021, I'm going to actually be doing some training on NFPA 72 as well as 70E, electrical safety in the workplace. So I know that gets some of you excited. I do have a background in that type of thing as well. So, but I've been resistant to doing it for years, but I am going to start doing a little bit of it in the 2021. Okay. All right. So what I want to look at is obviously, well, first things first, obviously the question was important because we're in branch circuits, right? And so we're in branch circuit. It didn't state anything otherwise, like it was a simplex single receptacle. It didn't talk about the receptacle at all. So we have to go with what's given in the question, okay? And so that's what we're working off of. So if we go down, you're going to see these nifty little tables. And I'm going to talk about these for a second, just so you kind of have a better, I'm going to make sure that they're on the screen because I want to make sure, okay, they're both on the screen. Okay. All right, look at the table, folks. Look at 210.21b2, total cord and plug connected load. That was what the question said, right? Cord and plug connected load. Now, if you look at it, you'll see that a 20 amp rated circuit, this was a 120 volt, 20 amp rated circuit. The receptacle rating is 20 amperes, but the maximum load is 16 amperes because it is a maximum cord and plug connected load to a receptacle. Okay. So now the interesting thing about this is, yeah, I get it. All the receptacles that are in your house, in your living room, your bedroom, and all this kind of stuff, theoretically, the load is not to exceed, let's say on a 15 amp branch circuit, just 15, it's not to exceed 12 amps. But we have no idea what somebody's going to plug into it, so we don't take that into consideration for the most part for general use and stuff. Where this becomes important is those receptacles that are under the counter, those receptacles that are for specific appliances that cord and plug, your dishwasher, your disposer, things like that. Then it becomes extremely important. Okay, so that's why this is so important to have a question like this, and that's why I think it's a great question, because it's saying, look, if you do have a load and you know what that load is, and you're plugging it cord and plug into a receptacle, you need to look and see what the load is of that appliance, that cord and plug appliance, because in this case, in our question, if it was a 20 amp circuit with a 20 amp rated receptacle, the appliance that's being cord and plug connected, the load itself can't exceed 16 amps. Kind of important to know, right? Yeah, important to know. And while we're here, I'm going to give you another little quick lesson because I see this wrong all the time. Now look at the table below that. Look at table 210.21b3, extremely important table, because this table is telling me what's the rating that's acceptable for the receptacle. Acceptable for the receptacle. How you like that? What is acceptable for a receptacle rating when it comes to the circuit that it's applied to? For example, if it's a 15 amp branch circuit, then the receptacle can't be rated greater than 15 amps. If it's a 20 amp rated circuit, the receptacle can be rated 15 or 20 amps. This is why in the kitchen, you see many people using 15 amp rated receptacles on a 20 amp small appliance branch circuit. It's okay. Now, where you see this the most is people want to buy the 15 amp GFCI. You know, the receptacle, I mean, the GFCI device, it goes in the receptacle, in the outlet box, that will be 15 amp rated, even though the circuit is still rated 20 amps, right? Because they cost a little less. But the code allows it to be 15 or 20 amp. Now, as you see here with a 30 amp, the rating of the device has to be 30 amps. With a 40 amp circuit, I get this question on the fast tracks all the time, and routinely students get this wrong. If it's a 40 amp rated circuit, you can use it on a 40 or a 50 amp rated device. And the same with a 50, has to be a 50 amp rated device. Now, anything that's over 50, the device has to be rated equal to or greater than the actual circuit. So it can't be less. So the rating of the receptacle, let's say on anything that's over 50, shall not be less than the branch circuit rating. Can it be higher? Yeah, but it can't be less than that branch circuit rating. Okay? So just a quick tip, because I run into this all the time, and people want to know what the heck does it mean. Okay? So Just figured I would discuss it while I'm here, and I hope that you will get something out of that. Hopefully you did. Okay. All right. So let's go on and answer this one. And there we go. 210.23a1. And again, it's all based on the concept of 20 amperes times 80%. Now, also, look at this reference, 210.23a1. That was not the reference we used. This table will give us that, and I use this as the shortcut to get there, okay? But while we're here, let's go look at 210.23a1 so we can see how beneficial that is for this equation. Now, I'm making sure my screen goes over there. Yes. Okay. Why is this one important? Okay, let's look at this one. Let's see here. Here we go. Okay, so what is it? 23A1? Right here. Check this out. Cord and plug, connected equipment, not fastened in place. Again, it's not. It's cord and plug connected. It's not fastened in place. Again, the rating of one cord and plug connected utilization equipment not fastened in place shall not exceed 80%. Okay. This rule right here is just being general for any cord and plug connected load to a receptacle. So it was important for me to explain it that way and only coming here and then talking about this application for cord and plug connected, not fastened in place. Why? Because it leaves me the opportunity, and I already knew the answers to these questions, so bear with me. I've looked at these questions a million times. That gives me the opportunity to talk about this one. I can't get it to highlight. So, well, I don't know what's going on with it. There. Oh. All right, I don't know what to. Anyway, you get it. It's utilization equipment fastened in place. Now, notice this one says, it says the total rating of utilization equipment fastened in place, other than luminaires, shall not exceed 50% of the branch circuit ampere rating where lighting units, cord and plug connect utilization equipment not fastened in place, or both are also supplied. Okay, so in this case, the total rating of utilization equipment that's fastened in place, other than luminaires, can't exceed 50% of whatever that branch circuit ampere rating is, of whatever the branch circuit is. If it's a 20 amp, 50% of that is 10 amps. You with me? Where lighting units, cord and plug connect utilization equipment not fastened in place, or both are also supplied. So what this means is, if I've got a fastened in place piece of equipment, okay, an appliance fastened in place, and it's fastened in place, and then I also, that same circuit is supplying, let's say, a receptacle that would be supplied by cord and plug, okay, that is not fastened in place. If that's the case, then the branch circuit that supplies to that utilization equipment that is fastened in place can exceed 50%. Okay? So, again, the rating of the equipment fastened in place shall not exceed 50% of the branch circuit. But it's with the caveats that it also supplies other cord and plug connected loads that are not fastened in place, or lighting units, okay, or both. Okay? So, again, it's kind of how you look at that thing. So, if that's not the case, then again, if it's utilization equipment fastened in place and it is not connected, supplied to other cord and plug connected equipment, or it's not connected to lighting, then that's the reason why I explained this first. Because it's still a appliance that's cord and plug connected that's connecting to a receptacle, and that would kick in 210.21b2. So I kind of did it in reverse to kind of explain it. This is your general. This is what the rating of the receptacle is. This is what the maximum rating for the cord and plug. Then I explained to you what happens when, again, it's equals to 80%. It all works the same. But if I'm dealing with something that's fastened in place, then if that's the case, then I can size a circuit based on whatever the rating is, okay? But if it's fastened in place and it's connected with a cord and plug, then if I don't have lighting on it and I don't have other non-fastened in place loads, then I still wouldn't be able to exceed 16 amperes if it was a 20 amp load and it was a cord and plug connected, even if that's the only thing on it. Okay? You with me? Because it's cord and plug. Now, if it's direct wired, okay, as long as it's not a continuous load, I can pull it all the way up to whatever the rating is of the circuit. Okay? All right, just kind of throwing some other stuff out there. There's no doubt in my mind that could get confusing and lost on you. But hey, I had to throw it out there anyway. Okay. Domingo says, Paul, just wanted to say thank you. I passed my master's using your Fast Tracks program. Absolutely. Excellent. Way to go, Domingo. I knew you could do it. There you go. All right, let's go to another question. And again, I'm explaining these things tonight for a reason. There's a reason why I went straight to 210.21b2, like all of you did, and then worked my way down to fastened in place, and then just cord and plug. Okay? There's a method to the madness. Just have to bear with me. If you don't like how I taught it, there's other educators out there. There's a great, well-known one down in Florida. Go, he's more than happy to teach you. All right, it's just the way I do it. Sorry. All right, so the next one. The service disconnecting means for each individual residential service shall consist of not more than blank fuse disconnect switches or circuit breaker enclosures. Okay? Now, this is something that's important because this was a change for 2020. Not so much the rule, but there was a component of this that you're not allowed to do anymore, and I'll just throw that in there in a minute. But many people refer to this as the disconnect rule, the number of throws. So give me a code reference and give me an answer so that we can go look it up. Okay. Now, if I'm looking up this for you that are going to use your code book, and remember I said dissecting it, first thing I want to look at is service disconnecting means. Okay. I can look up in the back under service disconnecting means. I also know that right off the bat, if I see service disconnecting means, that I know that this is in 230. And remember what I tell students all the time, create flashcards. Create them. Now, those in the Fast Tracks, I don't know how many students actually do this in the Fast Tracks, but you have the ability to create your own index cards in the Fast Tracks program. Unlimited numbers, and to test yourself. Okay? I like them. I use them all the time. I create fat tabs for it. If you're in the Fast Tracks program and you don't know how to do that, just email me, Alex. I'll explain how you create your own little index cards in the program. In real life, just get you a set of index cards, and on one side, write the code article. On the other side, write what it is. 230, services. 215, okay, feeders. 225, outside branch circuit and feeders. Okay, 430, motors. Make you these cards so that you can test yourself over and over. Because how this helps you is on an exam, I want to know right away. Now, for example, if I think this is services and I think it's disconnecting means, one thing that I might do is go to the front of the book and I might cheat and say, all right, I'm going to go to the actual content, table of contents, and I'm going to go to services in 230. And then if you look down real quick, you'll notice that part 6 deals with services. And so it's part 6 is dealing with service disconnecting means. So I might say, okay, well, it says go to page 95. Well, if I use bold scanning and I use the answers that are on the screen, or when you're taking your test, then you can go right to that in the code. So I would go to 230, and I get my code book. I'm going to that part. And then I'll look at it, and I say, okay, I'm at the part for, okay, boom, boom, and say, okay, I'm looking for, do I find it under service disconnects? Okay, there it is. We got part 6, service equipment disconnecting means. Okay. So then I'm going to bold scan, and when I say bold scan, hit the bolds looking for things that are in the question. And I hit these bold scans, and I see boom, 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 and I see maximum number of disconnects. And of course, you have an A and a B. And I will tell Daniel to look at it again. Even though the answer's right, the code reference is wrong. Okay? So again, 2020 NEC. So you look at it, and if you look at it, then you'll see where your answer comes from. Now, and that's a way that I use the table of contents, because if you have enough knowledge to know that you're dealing with a service and it's in the disconnecting means, I'll be honest with you, that part is only, it only goes from 230.70 up to 230.85. So I can probably real quickly, by the time I flip through the index, I could probably get my answers by using the question, the key points in it, the answers, and looking for those answers. Okay? And it would allow me to get the answer. Okay? So that's kind of one way to use the table of contents. Now, the only way the table of contents is going to be beneficial for you is if you have some knowledge of the code. And that's where Fast Tracks programs, things like we have, and be honest with you, there's other programs out there that will actually get you more familiar with the structure of the code, and it makes it a little easier. And I would say, Carlos, look again, look a little deeper, and you'll get it. That's not correct. So you're in the right area, but you're not reading the question. Okay. Okay. So let's go to the code, and I'll do it with you. Kind of show you how I would do this one. So one of the things that I would do is if I was in I don't know that I have access to the table of contents here. So hold on. I don't know if they don't give you the table of contents in the electronic version, sadly. So I can't look at the table of contents. But in yours, that's where I would look, the table of contents, and I would look under 230, and then I would look for disconnects, and that's what sent me to page 95, okay, which was part 6 of Article 230. Now, if I wanted to go the other direction, I could go into the index. And remember what I said, if you're new to the channel, we're taking our time and we're dissecting a question so that you know what the index can give you and what it cannot give you. So one of the things I might go is D. I might go to disconnecting means. This is going to help you because you're going to see whether that terminology is in there, because you could get a lot of questions on an exam with the term disconnecting means. So I'm going to look and see what is actually under disconnecting means, and there's a lot. And then I'm going to go down and see if it says if there's service under it. And I see service, and it says, voila, go to part 6. Okay? So I'm going to go to part 6. So there's 2 ways I could have gotten there, right? So again, that's kind of what we're doing. So let me go on and do that. So 230, and you're going to, so here you also could do this. Since this figure is here, you could actually see where it says, this is what it says in the index. I mean, the table of contents. Service equipment, disconnected means. There it is. Part 6, right there. You even come down here, and you can see service disconnection means. Part 6. Go to part 6. There's 3. And let's go a little further. And here we are. Here's part 6. Disconnecting means. That was in the question. And we're looking down here. And here you see the maximum number. You have general requirements. And then here's where it's going to tell you 2 to 6. Okay. So obviously 1 is, it's just a service disconnect. But this rule is telling you the maximum. I can go up to 6. So it's 6, as you see right there. And I don't know why things aren't highlighting, but that's the rule. Now, I will tell you, just as a code tip for the 2020 code, you no longer can have 6 service disconnects in a single enclosure. Okay? If you're on the 2020 NEC, so you had 6 main breakers, you can't do that anymore. Okay? The 6 throws in there, you can't do that. Now, you can do it for feeder panels, because obviously the feeder panel is being supplied by a breaker, so it's protected by a breaker. If you turn that off, then it doesn't matter. But in a service, there's no way to kill the power to those 6 disconnects in a single enclosure. So you're working on it, it's always going to be live. So they got rid of this rule and said, no, it's not going to work in a single enclosure. But you have other options. Like I said, you got 1, 2, 3, and 4. You can have it in 6 separate enclosures. You can have in a panel board with a main breaker. And you could have 6 of them with main breakers if you want 6 panels. You can have them in vertical sections or separate sections of switchboards where each one is separate. Okay, and so you can have the meter disconnects in a meter center as well that are by separate compartment. You could have 6 separate compartments. That's okay. But you just can't put them all in one single open cabinet anymore. It's not allowed under the code. Okay? All right. So anyway, that's where we got the 6. So let's kind of go back to question, and we're going to answer our 6. And there we go. 230.71 B. B. Not A. B. Okay? We're giving you a lot of information tonight. Hopefully you're absorbing it all and you're using your code book and getting used to maneuvering around. I'll have another drink. Wow, Paul, that is very unprofessional of you. I don't care. All right, so the next one is the front edge of a switch box installed in a wall constructed of wood shall be blank from the surface of the wall. Should it be A, set back a maximum of 1/4 inch, B, flush with or projecting outward, C, set back a maximum of 1/2 inch, and D, set back a maximum of 3/8 of an inch. Yes, Jamie, these are questions that are in some of the practice exams in the Fast Tracks program. Absolutely. All of my training that I do on Wednesday nights comes from the Fast Tracks program. All right, so again, take this question and dissect it. What are we asking you? We're sticking a switch box in a wall, and the wall covering is wood, and we want to know, can that box set recessed? Does it be flush, or does it protrude? What does it do? Now, I know you might think you know the answer, and you're liably itching to just blurt it out, but go look it up in the code. Now, for those that are new to the channel, as I say over and over again. Now, I did get a guy that sent me an email that says, Paul, you are too redundant. My response to that was, don't watch my videos. That is my teaching style. I say things over and over and over again because eventually it will sink in. Okay? Now, that's very frustrating for some students who get things very quickly, but that's not all the students that I teach. I teach students who have reading comprehension issues. I teach students that don't test well. I teach really quick students who really get it just like that. But you got to remember, I have to cater to every type of student. And I want to cater to every student. I want to see everybody be successful. Okay? Not just the ones that are just as smart as it can be. I want everybody to be successful. Okay? So this question, this has everything to do with the box. So it's about a box and how it sits. Okay? So one of the things that I might look up in the code, and let's go to boxes. Okay? So I might look up in a box if you got your code book. Again, I don't have the index in the electronic version. And you know what? I can't use a PDF version anymore that's just like the code because the NFPA doesn't make those anymore. So again, it's caused me to not be able to use indexes. That's why I've got mine, right? And in 2021, I will actually have a second camera that's actually going to be focused on my code book. Okay, so we've got a bunch of neat things that are going to hopefully come in 2021 that we're going to be bringing to the table because I want you to see how I look things up, right? All right, so we're talking about a switch box, but ultimately it's a box. So you would go to boxes, and we're looking at boxes. Now, let's see if anything under boxes would help me. Now, again, why do I tell you to use the index? Because if I tell you to go to boxes, you're going to read everything under boxes. That means you're going to get a better understanding subconsciously what's under boxes. So if you do this enough for every question, looking up the roots and important pieces, you're going to get better, because you don't want to spend your whole day during a test in the index. But if you do, you need to be very efficient with how you use the index. And that's why when we're practicing, I make you dissect every question, okay? Because I want you to be efficient. Okay, so let's look at boxes. Hopefully you're with me in the index under boxes, and look down and let's see if there's anything that would be beneficial. Okay. All right, now I see minimum depth of a box. That is 314.24. Now you're probably saying, yeah, that's not the question, Paul. It's not. But it's talking about something about a box, and it might be, if you can't find anything, it's a good place to start. But we also know that we're talking about boxes. So boxes are 314. So we do know that. So even if we have to resort to bold scanning, we do know what article we're dealing with. Okay, so I'm going to go back and look a little more and see if I've got anything else further down. Just keep looking. And we just kind of keep on going down. All right, now we noticed something that says wall or ceiling. Okay. And so wall or ceiling at 314.27a. Mikey, I know this is probably a bit of a delay, but when you have AC units, window units, there's an allowance for window units under the appliances in 422 as well as in 440 that are going to be a little different when it comes to allowances for those type of things. So I've got 314.27a, which is wall or ceiling. So I'm probably going to write that down because it seems like that's close to where we want to be. Okay. But here's the thing. I only sometimes need to be in the area, and then I use my bold scanning to look for things like front edge, surface of the wall, wood, things like that. And that's why I've said there's a tip getting used to that. Now, the NEC is not the holy grail. Okay? So when I'm looking at boxes, the only one that I'm going to use first is, as I'm going down through that, I think if you're following along with me, then I'm going to definitely write down 314.27a. So I'm going to write that down. If I'm in the exam, I'm going to write that down if I have to go to the index. So I'm going to write, remember what I said? I'm going to write 314 at the top. And underneath it, I'm going to put dot 27a as one that's of interest. Now, while I'm back here, I'm also going to look and see what else that I would have anything to do with that. So they call it a switch box. So while I'm back here, I'm just going to look under switch box just to look, because again, if anybody says, well, Paul, you don't have that much time on an exam, dude, please don't aggravate me tonight. I'm trying to explain how you use the index to dissect a question so that you become better at using the index less. Okay, hopefully that makes sense. There's always somebody out there who says, well, it sucks because I don't have enough time to do what you're doing. Then you don't get it. There's people out there that say in the fast tracks, don't use the templates because the templates aren't what you use for an exam. You're studying. Use the templates. It helps your memory. It helps you remember things. That's why we do it. Okay? Don't fight it. Don't fight it. Just follow my lesson. Listen to me. No need to fight it. Every student that fights it are not going to be successful. I'm just telling you. All right, so I'm looking under to see if there's anything for under switch bar. Now I'm looking under switches, and I just want to, while I'm here, I'm looking down in enclosures, switches. You know, nothing really that's going to help me that's any benefit for me. That's really nothing. So I'm just looking to see if there's anything. Okay, nothing. Okay, so boxes give me the best. So what I would do at this point is I would probably go to dot 27 and start looking left or right of 27 to see if I'm looking for something that helps me. The terms that are in the question. So let me go in my code book. You go in yours. Okay, because I'm not liking the answer I see on the screen. Just so you know, Daniel. All right, so 314.27 is where we're going to go to, just to our starting point. All right, so here I'm at, and I'm looking at to see if there's anything in this that helps me. Okay, and I'm like, okay, well, I don't know that. I mean, unless you already know the answer. Okay, if you already know the answer, okay, you're okay. But if you don't know the answer, then you got to look it up. All right, so the other thing that I would look up is the question is asking about what is when we say front edge, one of the terms that we use from the surface front edge is flush mount, surface mount. There's all different types of terminologies that we use, okay? So what I'm going to do is I'm going to look to the left. Anything that has to do with surface, flush, they're in the questions. I'm looking for 1/4 inch, 1/2 inch, 3/8 inch, projection, flush. And so I'm moving backwards and I'm bold scanning. I'm looking at the bold letters. That's what we call bold scanning. And then you read under it. I'm looking back to the left to the right. If I go to the right first, then I notice that it's not going to help me because it starts getting into other things and pulling and pull box sizing. So I'm going to go to the left and I'm looking at your bolds. That has nothing to do with what I'm talking about. Going to the left, there's supports at 314.23, 314.22, 314.21. There's repairing non-combustible surfaces. That's interesting to know, but nobody asked that question. Okay. And then I'm going back and, oh, check it out. 314.20 and 314.19. Well, this looks like it's pretty decent information, but 314.20 is talking about flush mounting. And when we say surface mounting, we have surface mounting means it mounts on the surface, and flush mounting means it installs recessed and it is flushed with the surface. So there's no way to tell you that in this type of question. That's an example of experience, right? I got Martin's talking, flushing rings, things like that. So Emmanuel, 312 doesn't deal with the boxes. 312, that deals with, it has its own rules, but 312 is really cabinets, cutout boxes, and meter socket enclosures. Not really what we're working with, and that type of thing. And Mike Sparky, I'm assuming 230 to 85, you're still up in services. So I would be at 314.20. Okay. Now, before we look at the answer, go back to the index and look under flush mount. Okay, because it didn't have that in the question, but I want to see if there's anything under flush. I look at all these terminologies. Spend my time doing this all the time. I don't see anything under flush. Okay. I look at the question. There's nothing else in there but boxes, and boxes would have put us in 314. Surface. Okay, I'm going to look under surface. So I'm going to go look under surface. I'm picking that term. Now, if you're saying, again, I don't have time to do this during an exam, you shouldn't be doing all this in the exam. We're doing this exercise to learn the index. So I'm looking and I'm reading it and I'm looking surface. Okay. Surface, now I'm in the surface metal raceways. Surface metal race didn't really help me anything. Surface, no. So the only way that I would have gotten here for me is to go to 314 and bold scan. Okay. Looking for it. Okay. So in this case, under 314.20, it says flush mount, which is, again, different than surface mount. It says, if you look, installation within the surface, it's the last part of well, you know what? Let's go to the code. I'll make sure we all get it. All right, we're in the code, and I'm going to go to, now just for, see, so this is cabinets, cutout boxes, and meter socket enclosures. Okay, a cutout box is like a disconnect. Cabinet would be the cabinet that your panel board goes in it, or something goes in a cabinet. A meter socket. So what we're talking about is here in 314. Okay, and once you get a little bit used to 314, you wouldn't have had to do what I did at the index. You should know to immediately jump to 314. If you're savvy with boxes and you know that's 314, and you start looking at it, and what you're going to notice is right here where it says, again, this is a flush mount, but in the question, they didn't say flush mount, okay? But they described what it would be flush mount, but they didn't say it. And you're going to get a lot of questions like that on an exam. Sometimes you just wish they would just say it, but they don't. It's the way they write it. So in this case right here, we're talking about, so in our part, if it was gypsum board, it was non-combustible, then it could sit back 1/4 inch. If it's combustible, like wood or other combustible surface material, boxes, plaster rings, extension rings, and listed extenders shall extend to the finished surface or project therefrom. So basically the box or the plaster ring or the extender has to be flush, or it can protrude out. You know what? Protruding out sometimes can be a bit nasty because it causes the cover to sit a bit proud of the wall. So that doesn't look too good. But at the end of the day, it needs to be flush with or project out. Okay? So that was just kind of an example of that question was written in a way that you might have found it if it said flush, right? But this was a great example where the index didn't benefit you much. Now, let me show you something you do after you already answer the question. Okay, let me show you something you do. Once we know that it's flush and we found our answer, I always like to go back to boxes in the back of the book. Okay, now let me show you why. I like to go back to boxes and then look at the code references and see which one of them gave me the answer. So let's go in and get the answer, and then we'll use the answer to reverse engineer the question and see what terminology, or was there a reference in there that would have put me right to dot 20, and is it reasonable in the question? So let's kind of answer the question. And 314.20, so we established that's what it is. So let's go back to boxes in the index, and let's look at all the code references and see if we find a dot 20. And I'm going to look down and see if I see it. Well, there was a flush mount installation in 314.19. Okay. There is a, keep on going down. I'm looking like you should be looking. All right, so what we did have was concealed work, but I'm being honest with you, that question would not have driven me to concealed. I just wouldn't have. Okay, I think of concealed work as something a little different. So that wouldn't have been intuitively drawing me there. But now that you know that, it might help you further on if you get a question that's very similar. Okay. Now, I will tell you this. The people that are in the Fast Tracks program that are learning the code, this question, so let me give you another example of what I recommend when you're taking an exam, since I'm giving you a lot of stuff tonight. You need to take an exam in 3 waves. 3. The first wave you go through, you answer the questions that you just flat out know. You know. And the ones that you don't know, or the ones that take you longer than a minute, you want to tick the little checkbox to come back and review it later. Then go to the next question. Read that question. If you can answer it right away, answer it and move on. If you can't, and you spend over about a minute or so looking for it, or a little longer if you want, close as you can, you still can't find it, check it and go to the next one. You want to answer all the questions in the first wave that you know right away. Save the second wave for all of those that you checked. Now, if you're in a state that doesn't have 2 separate exams for calculations versus code lookup, like Texas is 2 separate exams, you're welcome. And some states, like Virginia and others, they put the calculations in with the regular code questions. Always skip the calculations unless it's really, really easy, like it's an Ohm's Law question or something like that. Always skip them. And mark it. Check it. So you go to the next question. Okay? Don't leave it unchecked. Okay? Skip it. Mark it and go to the next question. Once you go through that first wave, you come back. And in the second wave, they're the ones where you get to spend 2 full minutes looking for a question. Okay? If you can't find it in 2 minutes, leave it checked, go to the next one. Okay? And move through like that. And then the third wave is where you have to give an answer. If you get to one of those that are checked, you have got to give an answer. Okay? Right, wrong, at that stage you're guessing. But you're going to have to give an answer. But then when you get to a calculation, you need to take the time to work your calculations. Okay? So it's kind of a 3-wave method that you go through it. But the reason you're going through the first ones and answering what you know is because you're trying to buy you a bank of time so that you can use it later. Right? If I answer 35 questions that I get 2 minutes per question, but I only spend a minute or even less. Some of these questions, like this question on an exam, I would have answered this right away because I knew it. I studied it in the program. I would have answered it right away. Guess what I just gave myself? 2 freaking minutes. Do that over and over again. You're going to create a bank of time. And it's going to be beneficial for you as you move down, as you go through it. So that's why we do that. And it also gives you more confidence as you're doing the exam. Okay? And I really want you guys going in there with confidence. Do not go in there with the think, oh my God, I'm not ready. Okay? Study with a plan. Study with a purpose. Study with intent. And this is why I'm teaching you how to dissect a question. Joel said, study with a purpose. He must have heard me say that over and over and over again. So yes, you got to study with a purpose, with a plan, with intent, with dedication, with motivation. This is your livelihood. This is taking you to the next level. I mean, it's big stuff, and it means a lot. People can tell you every day that piece of paper don't mean anything. They're full of crap. Full of crap. Paul said you're full of crap. It means everything. Not just to what you do, but to your self-esteem, everything. All right, next question. All right. When doing box fill calculations, got some box fill coming up. A luminaire stud or hickey in a ceiling-mounted outlet box is an equivalent to blank conductors based on the largest conductor in the box. Okay? So, look this one up and see what you can see. See what you look it up. So in this case, what we're talking about. So obviously a savvy code person knows we're talking about box fill. Give me code references. I want code references. I have folks that are in the Fast Tracks program, and you spend your hard-earned money to get in that program, and they submit their units, and they submit the units without giving me code references. I will not grade their reviews. I reject them. I give them a 0. And if they complain to me, I just delete it. I won't read your email because I cannot judge your progress if I don't have a code reference that supports your answer. Okay? And that's just how my program works. I am not like other educators. I am blunt, but I also like to have fun, and we want to learn the code. And, there you go, Martin. You didn't give an answer, though. Give me an answer. I need a number. Give me a reference, but I need a number. So, in 314.16 is a little bit broad, Martin. Kind of pin it down a little bit. Kind of narrow the code reference down slightly. Okay? So, we're dealing with box fill. So, we know what article we're in, 314. Now, we're just focusing on what section and then what subdivision that we might have underneath that section. Okay? So, some people call them subparts, but it's actually subdivisions when you break it down into other levels underneath the code section. There you go. You're starting to break it down. So, we're talking about stud and hickeys right now. Remember we said dissecting. Dissecting. The question says luminaire, stud, and hickey. Okay? And we have outlet box. So I'm going to go back to the index again. And I want to look and see if I see anything in here that says anything about luminaire, studs, or hickeys. Remember what I said? Go to boxes, look under boxes. Now I see it says number of conductors in a box, 314.16. Like we said, that's at least going to get me in the area. And you should know by now 314.16 has to do with box fill. Okay? If there's anything you commit to memory on that, remember, 314.16 is box fill. And I'm going to go there and give you some little tidbits of advice for you students that are studying when we get to it. Now notice, Joel, it says luminaire, stud, or hickey. Okay? All right, so I'm looking there. Now the next thing I'm going to look for craps and giggles, I'm going to look under hickey. Because believe it or not, it is a trade term, and I just want to look. Again, you know what? I've been doing this for 30 plus years. I still love doing this. I still love, you people can say, Paul, get a life. Well, haters are going to be what they are, but this is my life. I love the National Electrical Code. I love teaching electricians. I love seeing people be successful. So let's look and see what we've got under hickeys. So under hickeys, let's see if we've got anything under it, because that's a key thing when you're studying the NEC, is look and see what you've got. So let's see if there happen to be anything under hickeys. And I doubt it, but we'll look. I don't see anything under hickeys, so that was a big. Didn't have anything under hickeys. Okay, what about luminaire stud? I'm going to look under luminaire stud. And I'm looking under luminaires just because I'm looking. Again, we're just studying. We're just practicing. We're trying to get used to looking at the code book. So I'm looking under luminaires, and I real quickly can look under see if there's anything under luminaire studs. And I don't see anything. I do see supports, but it doesn't give me any reference to anything. So I don't see anything under there that would help me with any of that. Okay. So what else might we look under? Well, there's not going to be anything under box fill. I can promise you that one, right? Okay. There you go, Martin. Now you're working. Now you're cooking with grease. Oh, there is something under luminaire stud in at the end. It says luminaire stud, but then it tells me to look at 410.36C. Well, immediately your mind's thinking I'm going to go to 410 because that's luminaires, but we know that we're talking about box fill. Luminaire stud going into 410, you have done this long enough, you know that ain't got nothing to do with box fill. Okay? So that's a misdirection. That ain't going to help us any. So let's go to 314. And I'll show you that if I didn't know anything else, I'm going to show you how to bold scan. So we know that 314.16 is the general area that we go for box fill. So we're going to go to the code and look it up. And I'm already there. I'm going to 314. So all of you that are code savvy, you know that 314 is boxes, but 314.16 is where we start getting in all the little pieces that have to do with box fill. So here's 314.16 right here. And we start bold scanning. What am I looking for? Luminaire studs and hickeys. That's what the question was about. So I'm looking here, standard boxes, outlet boxes, box fill calcs under B. There's a box fill. There's a clamps, support fittings, devices. Support fittings. Luminaire studs or hickeys. What I can't express more to you is that it's important to understand terminologies. Okay? A luminaire stud and a hickey are supporting devices. They actually support the weight, or rod, or luminaire, or a screw-in rod. They actually mount in the box. Some cases they screw straight through the box into wood. They support the weight of a luminaire, whether it's on a swag chain or whether or not it's on an actual rod, threaded rod. That is a luminaire stud or a hickey. Now here's what it says. It says where one or more luminaires, let me make sure it's on the screen because I can't see exactly what you see. Okay, there we go. Just wanted to check. It says where one or more luminaire studs or hickeys are present in a box, a single volume allowance in accordance with table 314.16b shall be made for each type of fitting based on the largest conductor present in the box. Okay? So largest conductor, if it was 14 gauges in the box, then there you go. It'd be 14, and it would have a cubic inch volume of 2.00. Okay? But when we say it has a single volume, that is equivalent to saying it equates to one conductor when you're doing a volume count, right? So in other words, I have let's say 14 conductors in a box, or 3 14-2s in a box. So that's 3 blacks, 3 whites, but I also have an equipment ground. Okay, so that would be total of 3 blacks, 3 whites. That's 6, and we have the equipment ground, which is 7. Okay, but if we had a hickey in there, that would be equivalent to 8. You treat it like a conductor. You with me? So that would be 8. So if the volume, if it's 14 gauge and it's 2.00 cubic inch, then 8 would be 2.00 times 8. So it would be 16 cubic inches that those conductors and that hickey take up of that box. And then we have to look at the box. If it's a non-metallic box, it'll have stamped its cubic inch. If it's a metal box, then you can come here for all your standard metal boxes. And here's where you get your cubic inch volumes, right here in this column, right here. Okay, all these right here. Now, what is this for? This is kind of a shortcut method. This means if all of the conductors in the box are the same size, then we can look at it and say, well, how many 12s can I put in this box if they're all the same size? How many 12 conductors? Remembering that a hickey equates to 1 conductor. A receptacle equates to 2 conductors. You with me? Okay, a switch equates to 2 conductors. It's called a double volume, basically 2 conductors. So, for example, if I ask you how many conductors can I have in a 4 11/16 by 1.5 inch square box? Well, it's 25.5 cubic inches, right? But if 12 conductors, I can have 11 in there. And that might be 11 individual conductors, or it might be 1 receptacle with 9 individual conductors, because a receptacle is a double volume. It counts as 2 conductors. So it would be 9 individual conductors plus 2 conductor, which is a double volume for the device. So that's what this is for. This is kind of already does it for you. Now, if all the conductors are not the same size, this isn't going to do you any good. You still need to know the cubic inches, But then you got to come down here and you got to start doing the math, okay? Box fill. And I have a video on that over on our YouTube channel if you don't understand box fill. And I have some live streams that we have done box fill together. So hopefully you get that. But anyway, so your answer should have been down here. It should have been 314.16B3, and it's a single volume count, so it is 1. And I'm selfishly took that moment to be able to explain a bunch of different things while we were there, since I'm already there. Oh, I should tell you something else. If 314.16 for metal boxes tells you in that table what the volume is, but the box itself from the manufacturer has a different volume stamped in it, guess which one you get to use? You get to use the box because that's the manufacturer. They told you what the volume was. That's a beautiful thing. If the table says it's 22.5 cubic inches, but the box says that it's 23.5 cubic inches, dude, I want to use what? I want to use the cubic inches that's stamped in the box. I don't do Canadian codes. Sorry, I don't do anything with Canadian codes. Want nothing to do with Canadian codes at all. Nothing to do with it. I'm a National Electrical Code guy. Sorry. All right, so let's answer the question. And I can't stand the Canadian code. So let's answer the question right there. 314.16B3. So I'm giving you a bunch of stuff. So let's kind of work through this one here. All right, you ready? Next. A branch circuit supplying more than one, okay, electric baseboard heater in a residential occupancy shall be rated a maximum of blank amperes, okay? In a branch circuit supplying more than one baseboard heater in a residential occupancy shall be rated a maximum of blank amperes. Give it a shot. See what you get. Okay. Now, one thing I'm looking at here is it is a branch circuit. So it's talking about a branch circuit. Okay. So I've got things I want to worry about that. And again, it's supplying more than one electric baseboard heater. Residential, could have said dwelling. Doesn't really matter. Occupancy shall have a rating, a maximum of blank amperes. Okay. So we have a maximum requirement here. Let's look it up, because you know what? We don't want to assume this question's written right, because there's a lot of questions you're going to run into that might not be written well. Okay? So I'm going to look it up. You look it up too. See if you can dissect it. Okay? With what you're looking for. I'm going to look it as well and see if I can find the answer. And we'll kind of work from there. So take the time, look it up, and I'm going to read some of these questions here. I'm not sure what an LLE is and a CE is, Mr. Bo. We're working in the 2020, Joel. I don't work in the 2017 anymore when I do these things. Always the latest edition of the code. But as you can see, the 17 is working out. There wasn't any big changes with that, right? Nothing huge things like that. Okay. So kind of look in the code, look at it a little bit, see what you can find. Look up your answers. Again, we're talking about a branch circuit supplying more than one electric baseboard heater in a residential occupancy. Okay. Oh, wait a minute. While y'all are looking that up, I got something I got to reply because I am on call for my work. So hold on. I gotta make sure y'all look it up. I don't see any activity in the chat, so look it up. Okay. Sorry, guys. I'm giving you time to look this question up while I try to answer this question here. Because I gotta. Oh. What? Okay. Sorry about that. All right. What do we got? What do we got? What do we got? Okay. Sorry about that. Looks like Jay's come back from eating. There's no emergency at work, so I'm good to go. All right. So let's dissect this. So we're talking about a branch circuit. So I might look in the back of the book under branch circuits. And I might look at, and you know what's amazing? That I was opening my code book and I opened it to basements. And I looked right down and it was basements. And all of a sudden I look at the computer and I see Jay Grunberg. Basement King. Hold on. I got music for that. Okay. All right. So let's see here. I'm going to look at, so if I look under branch circuits and I look and I see, what are we talking about? We're talking about one, more than one, blah, blah, blah. But we're looking at fixed electric space heating equipment. So one of the things that kicks into my mind is this is one that's kind of looking like it's going to lead me to 424. Okay? So, and if you didn't believe me, I ain't lying to you. Basements right there. Open it up and just immediately. Basement. Tell you what. Here's what we're going to do. We're going to test the Basement King. You ready? I'm going to put Jay on the spot. Let's test the Basement King. He said 30. There you go. Remember I said something told me I had to go to 424? All right. But I felt confident that I wasn't going to cause him. But he's looking at 424.4a, and we say 424.3a. So there's a .3 and .a. Let's see if Jay's right. And let's see if the author of this code question is wrong in his code reference, because I can be honest with you, sometimes the author of these code questions are wrong. So let's go and look. Not a lot of times, a few of them here and there. And I like to see if students find it. But I got to 424 because I went to branch circuits, and I know that we're talking about fixed space heating. Okay, that's what it is, baseboard heat. Okay, you got to learn the terminologies, and that's beneficial. So we're going to 424, yep. And let's look at it. So Jay says it's 424.4a, and we'll look at the reference here as 424.3a. Well, let's go. Let's see. And I confess, I knew when I was going to answer this, and I knew that my Basement King was going to get a whoop whoop. Making you look good, Jay. You did a good job. All right, so I'm looking here in 424.3, but the answer is in 424.4a at the bottom where it says branch circuit supplying two more outlets for fixed electric space heating equipment shall be rated not over 30 amperes. And that's where he got it. Okay. Now, you could look at, I don't know, is baseboard heating in the index? I don't know. Let's go look. I didn't think it was, but let's go look. You're doing good. But Daniel, that's the point. you'll forever know if it's not, that you never do it again. So let's go look. It might be baseboard heating in there. Let's go look. Let's see what we got. Basement King. Let's see, base. No, it doesn't look like there's anything on there for baseboard, is it? Nope. So again, you were looking there, but now you know it's not. I would have gone to branch circuits because that was the premise of the question, right? It was talking about a branch circuit. So something told me that I want to look under branch circuits. Now, I didn't want to look under 210 because this question is asking about the branch circuit supplying more than one electric baseboard heater, which is a fixed electric heating. I wanted to remember that 424 is going to give me that direction. Okay, and that's how I got to it. Now, if you look in the back, I'm also going to give you, if you know what electric baseboard is, then you know it's fixed electric heating. So go look in the index under fixed and see what you see. I'm just going to look and see if there's anything under fixed. There we go. I see fixed electric, fixed equipment, fixed electric space heating equipment. That's what that is. So you'll forever remember that a baseboard heater is considered fixed electric space heating. How about that? There you go. Look. Beautiful moment. Now, look what it says. The second one, it goes branch circuits. 424.4. Branch circuits. Boom. That's what we're looking for. Okay, now let's look and see, while we're here, let's look and see if there's anything else in there that might say something like rating or, yada, yada, yada. And I'm just looking because I'm here because that's why you're doing this. I want to learn what's in here. Clearances and ceilings, important. All those type of real. Okay, so we would have found the answer that way under fixed. What ultimately ended up sending us where we needed to be. So, perfect. Great job, Basement King. And he even proved that the actual information in one of these practice quizzes is wrong. Now, again, the reason I went right to Jay is because, one, he did awesome. He knew it. He's a fast track student. But two, I knew that the code reference it was going to pop up wrong anyway, so sorry. But it made for good entertainment, you got to admit. All right, yes, and there's many ways to do it. Daniel, you had to look under branch circuits, and you had to know that it was fixed heating. And there's no way the index is going to help you unless you know terminologies. Okay? So, again, the index is not the holy grail. You could have looked under fixed electric space heating, or you looked under branch circuits. Either way, that would have got you to 424.4, and that's what you would have gotten your answer. All right, look at the one on the screen. It says there's a given here. So a given, it says the ungrounded service entrance conductors for a one-family residence are size 3/0 THWN copper conductors. A copper grounding electrode conductor attached to the concrete encased steel reinforcing bars used as the grounding electrode shall not be smaller than size what? Now, Pedro 250.66 doesn't give me anything. Okay? So, again, we need to be a little more. Now, when you throw in a code reference out, and you're throwing an answer out, make sure you're giving it. So, because here's what it's saying. Okay? It's saying ungrounded service entrance conductors of a one-family dwelling, size 3/0 THWN copper, a copper grounding electroconductor attached to a concrete encased steel reinforced bar, which is a concrete encased electrode. Okay? U for ground, as a grounding electrode shall not be smaller than size what? So I'm getting some answers here. I'm going to say look a little harder. and we'll look in the code book. Okay. Okay, I've got some answers coming in, got some code sections, but I'm not getting code answers with code sections. I'm getting code sections with no answers, and I'm getting answers with no code sections. I get it. The chat's slow, but most of the people know that I want code reference and the answer following, or vice versa. But again, we'll do the best we can. We'll do the best we can. Daniel, that doesn't help us. That doesn't answer the question. Okay, so let's go look at this and see what we're talking about. So first things first. A concrete encased steel reinforcing bar is a concrete encased electrode. Now the question already assumes that it is a qualifying electrode, right? Already assumes it, okay? And so I'm getting a lot of answers here, and I'm not sure, Daniel, that you're actually looking up the information, to be honest with you. At this point, I'm not sure that you're actually looking it up, or just guessing. So concrete case. So one of the things that I tell people in this one is to go back to the index, and go under electrodes. It's the first place I'd go if I was going to go back in there. That's okay, Daniel. That's what we're here for, brother. That's what we're here for. And we go to electrodes, and I go down the electrodes, and I'm looking for concrete encased. And obviously it's right there. So 250.50, which is not going to really tell you about the concrete. 250.50 is your charging statement for your electrodes. Okay, it starts right there. It tells you got to tie all electrodes together. They're treated as one when they're all tied together, all that kind of good stuff. But what you'll see is 250.52A3. And remember what I said? I'm giving you a tip. If you have to use it, okay? You're not there yet, Daniel. All right, so what I tell people to do is when they write these things down, here's what I tell you to do, okay? I tell you, if you get here and you see concrete encased electrode, you write down what it is. So it's 250. So I write 250 on your scratch paper, just like that. Okay, and then underneath it, I write just the sections. So .50, even though we already know that's not it, I write .50, I write .52, A3, I write .66B, I write .68, A, exception number 1, and then I write .70. Well, why do I write all these down? I write these down because I don't want to come here again. That's why they give you scratch paper. Okay? So, once I know I'm where I need to be, I'm talking about concrete encased electrodes, then I can go, and I go to the very first one, I'll go to the .50. And again, you got tabs for this. Use your tabs. I've got those sucky tabs, not my P tabs. I've got these, on this one, I got those see-through tabs that ain't worth a poot, right? Ain't worth a poot. Yeah, I should replace them with my tabs, but I'm lazy like that. All right, so I'm going to go to 250.50 first, and immediately you'll notice that has nothing to do with what we're talking about, okay? So you look at it real quick on your little list, and you would mark that one off. I'd go 250.50, okay? Remember, time is limited, but when we're studying, you can take your time. But on an exam, if you did this, you're getting there quickly and you're looking at it and go, it has nothing with these answers in it. Mark it off. .52, A3, concrete encased electrode. I get it. It tells me how to size it, what the length is, but it doesn't tell me the size of the grounding electrode conductor. It just talks about the electrode. Benefit, doesn't help me any. .66, I go to .66 next. I noticed that 250.66 says sizing of alternating current grounding electrode conductors. I see this table, 250.66. Okay, but I don't necessarily go to the table right away. Why? Because I read it. It says, the size of the grounding electrode conductor at the service at each building or structure where supplied by a feeder or branch circuit or at the separately derived system of a grounded or ungrounded AC system shall not be less than given in table 250.66 except as permitted in 250.66a through C. So I immediately got to go look at A through C. I immediately got to go look at it. Okay, Daniel, you're wrong again. All right, so I'm going to go look. That reference you gave, Daniel, has nothing to do with sizing the grounding electrode conductor. So I'm going to go look at A, B, and C. Well, quickly, I'll look at it and notice that B is the only one that deals with concrete encased electrodes. It's the only one. And here's what it says. It says, if the grounding electrode conductor or bonding jumper connected to a single or multiple concrete encased electrodes, as described in 250.52a3, okay, does not extend to other types of electrodes that require a larger size of conductor, never referenced in the question, so not an issue. It says the grounding electrode conductor shall not be required to be larger than a 4. Okay? Not required to be larger than a 4. So now let's read the question. Okay? It says, ungrounded service entrance conductors for a one-family residence are size 3/0 THWN copper conductor. The copper grounding electrode conductor attached to the concrete encased steel reinforced bars used as a grounding electrode shall not be smaller than size what? All right, you ready? Okay. Let me show you what happens. Okay. And now I'm going to show you why I was a little easy. Okay. Let's go back. Let's look at the question. You ready? Okay. Hold on. Let me. Yep. You ready? .250.66. Okay. Now you all can talk to Daniel now. Hold on. Let me go back to the. Wait a minute. Let me make sure what I'm on. There. For all of you that I read it and you immediately jumped to 250.66b, didn't you? Right? No, it's not 2. All right. So why do you think it's table 250.66 and not 250.66b? Because, now this is subtle. Jay will like this. Let's go to the code. I want to read it to you. This is why I kept saying Daniel, because he had the wrong size and he kept going back to the table. But he was closer than most people who simply gave 250.66b because of the wording of the question. Let's show you. That's why we do these things. All right, let's go to that real quick and I'll show you this. Pretty interesting how this question was worded. This is why we do this. All right. Now, it just so happens that 250.66b says it doesn't have to be larger than a 4. I get it. This is an example of where the answer just happened to work out. But watch this. You ready? So this right here, okay, says that it's not required to be larger than a 4, right? That's not what the question says. It says the grounding electrode shall not be smaller than. You see it? And why is it important that it gave it 3/0 copper? Because it says that it doesn't have to be larger than a 4. But the question was, it shall not be smaller than what? And in that case, you had to go to the table. And so if you look at the table, the 3/0 copper right here is a 4/0 copper. Okay. Why is that important? Because there are times when the code says it doesn't have to be larger. Take a ground rod. Okay, check this out. Let me just give you an example. See this ground rod? If I go to ground rods, it says right here that it doesn't have to be larger than a 6, right? Right? But if I have a 100 amp service, what is the size of the conductor for a 100 amp service? Well, I'll jump to the chase because if we can apply 310.12, for example, let me just show you so we can kind of finish this loop. Let me just show you what I'm doing this. Oops. Dang on it. Bear with me. All right. 310.12 says 100 amp could be a 4 if you meet all these rules. In fact, a 125 could be a 2 if you meet all these rules. It's that little mini table that we talked about. So what if it's a 100 amp service and it's a 4 copper? Okay. Or even all the way up to, let's say, a 125, let's say it's a 2. Okay. And I have ground rods. Well, check this out. The reason I'm bringing this up for you folks. So this says if it does to a ground rod, it doesn't have to be larger than a 6 copper, right? But what if it was that 4 gauge or that 2 gauge? Remember, for that 100 amp service or 125? Well, then it says the grounding electroconductor only has to be an 8, and 8 is smaller than a 6. So yes, if I'm not using the allowance in A, then I could have a grounding electroconductor that goes to a ground rod that is smaller than a 6. It could be an 8, and that would be okay. The only thing you got to worry about is when it's smaller than a 6 and it's subject to physical damage, then you need to protect it in some type of raceway. Okay? But other than that, I just wanted to prove the point that if I don't use these, then you default to the table. Okay? Make sense? Great exercise. I'm glad that worked out the way it did. Hopefully you learned something about it, you know, that type of thing. Okay? Now, 250.52.32. Let's look real quick. 250.52, would you say? 250.52.32? No, that's not what it says, Joel, because that's talking about the electrode itself. A bare piece of copper 20 feet in the slab, in the foundation or footing, that qualifies as an electrode. We're talking about the grounding electrode conductor. 2 different things, right? It just so happens that 4 works out. But it is 2 separate things. Let's keep them separate. That way we avoid mass confusion. Okay? Anyway, that's a good lesson. All right. Here's a good one for you. Knock it out. What do we got here? For dwelling units, panel boards are permitted to be located in all of the following areas except kitchens, bathrooms, garages, or hallways. Okay? You're most welcome, Daniel. Hopefully you got something out. I used you as an example so that I could go deeper for everybody, and I hope you get it, why I did that. It wasn't to call you out. It was because I want you to work through these things and really let it sink in, because that's something now you'll never forget. And it's really important that people really know how to use 250.66 and A, B, and C. You don't always run 6 to ground rods. If this is a 100 amp service, a 125 amp service, I could run an 8 gauge to my ground rods. It just doesn't have to be larger than a 6. That means even a concrete encased electrode application, when it comes to grounding electroconductor, it could be smaller than a 4. Because it doesn't have to be larger, right? But it certainly could end up being smaller. You know what I'm saying? So there you go. All right. So answer this question on the screen, folks, and we're gonna end it tonight, unless anybody's got any questions. For dwelling units, panel boards are permitted to be located in the following areas except. Okay. So this is all about where you can put a panel board. Okay. Kitchens, bathrooms, garages, and hallways. Now the trick to this one is to also know that when it's talking about panel boards, that it also, most all the panel boards have an overcurrent protective device on it as well. Okay. Yeah, you have main lug onlys. Okay. So we have rules for that. But in this one, again, let's look at the question. Okay, and you're right. So if I'm on an exam, this one is one that I am going to pray that you all answer this in less than 5 seconds, and you just bought yourself a bank of time and you move on. These are the kind of questions that you should just be able to answer. Okay, but let's say you didn't. Okay, this is how we do things here. We go look. Let's look under panel boards. And let me look under panel boards, as y'all can hear my papers. So here's panel boards, and we're going to look here, and we're going to look and see if there's anything under panel boards. Okay? Is anything that, might be beneficial for us under panel boards? And I'm going to panel boards for a reason, because this is more about the protection in a panel board than it is about the panel board. But let's kind of look at it, because that's what I want to look at. So let's kind of look down and we see, I don't see anything. Installation, but that's nothing to do with it. Overcurrent protection, okay, in a panel board. All right, so that might be something. But I'm looking down and I'm seeing circuit breakers and fuses in panel boards and power. So again, the index is not the holy grail. This is an example where you got to know a little bit about the panel board. Now, again, it could be that the person writing the question didn't write a good question. Okay? I mean, it might be a better question if he says for dwelling units, a panel board with a main breaker are permitted to be located in the following. I mean, could have said it that way, right? It made maybe a little easier. Okay? That type of thing. Okay? So, all right. So that's one thing. But let's go from the backwoods direction. Let's look at where, for example, it says 408.36 when it comes to overcurrent protection, because I don't see anything else in here that limits, but I see 408.36 and I see enclosures 408.38. So let's, for craps and giggles, let's go to 408 before I go to where I really think you should know to go. Okay, so let's go to 408 just to go there, and that isn't where you're going to find all your panel board rules. Okay, now, oh, look who's late to the party. Look who's late to the party. Okay. So now let's look under panel boards, and a couple things that I want to tell you about this is you don't need to look in part 3 because that's switchboard and switchgear. That eliminates a lot for you. So I don't have to look in that type of thing. It doesn't mean that's where I need to do anything. So I don't look there. And what I'm going to do is I'm just going to look at the bowls. I'm looking at the bowls and see if there's anything that has to do that would help me here, even though I don't feel like this is where I want to be, but we're going to do it because that's our exercise. So I'm going to look at it, look at the bowls, boom, 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 and look at panel boards, okay? And I'm looking down. I don't really care too much about part 2 because that ain't got a jack to do with panel boards. Jump to part 3, panel boards, boom, overcurrent protection. Boom, look at that. Doesn't really help me. Just looking, folks. Boom, 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 boom. Enclosures, cabinets, cutout boxes, difference, blah, blah, blah. Relative arrangement, I don't care about that. Grounding band, orientation. Okay, I don't care about that in this question anyway. Then construction specifications. That doesn't help me anything. So by this time, I should know that we're talking really about the protection that's in the panel board, the overcurrent devices. Now, why am I saying it this way? Look, if I got this question on an exam and it did say main breaker, don't hinge on a main breaker, because what else is installed in a panel board? What's the nature of a panel board? What do you plug onto panel boards? Overcurrent devices, breakers. So that should have already got you to 240. So you see the method of the madness here? I want you to dissect the question, and you got to learn a little bit of your knowledge. We just looked at panel boards and nothing really helped, except for the fact that reading it triggered in our mind overcurrent protection. Overcurrent protection, 240. That's the issue. So then we can do what? Go to overcurrent protection. All right, so go to the index and look under overcurrent protection. Okay, I'm hoping by now you know the answer to this question, but if you didn't, go to overcurrent protection. And element O, and I am, so I'm going to overcurrent protection, and I'm going to look down it, and I'm going to look down it and see if I see anything. Overcurrent devices, overcurrent protection. I'm looking down it, and what are we looking for? Okay, we're looking for something that talks about prohibited locations or something like that. So I'm looking down, and I'm looking at it. Enclosures, looking to see if there's anything that it talks about prohibited locations. Okay. Panel boards didn't help me with that one. Okay, service equipment. I'm still looking. I'm looking. All right. Unless I missed it, I see nothing in here that would be beneficial to me that talks about it. And I was kind of hoping there was something in there, and maybe I looked at it just a little too quickly. Let me go back and look at it again, because I was hoping there was something in there. Because you can't go over it too quickly. And let's see what we've got. Fixed, flexible for the fuses, Oh, okay. Well, not so much to be beneficial to me to look at that one, but I won't even mention it because it would be a occupancy access to. Didn't help me much. Find your own ways, guys. Look at the index. I'm trying to look and see if there's anything in here that would remotely get me to where I needed to be positioned. Okay? I don't know that I see anything in there that would point me directly to that. Now, in the question, you have 4 choices: kitchen, bathroom, garage, and hallways. Now, I can tell you that in the index, you'll have terms like bathroom, okay? And you can look up bathroom or kitchen, things like that. But nothing right here. Now, nothing would tell me to go to bathrooms. Nothing tells me to go to garages. Nothing tells me to go to hallways. So at the end of the day, there's nothing in there that was beneficial, okay? So the other thing that I would look under would be location, okay? So I'm going to look under location and see if I see anything under location or locations or anything like that. There's locations in the back, and I'm looking at locations, and I go down under locations, and I'm seeing if there's anything under locations. Overcurrent devices, locations, says part 2. Okay, so that's beneficial for me. I'm looking at anything else since I'm already back here. Again, you probably already answered this question and went on. Why are we dissecting it? Because I'm taking an opportunity to look at all these locations so that in my mind, if I have another question as I'm doing the exam, I'll be able to come back to it. But as you practice, you're going to learn what the index is good for and what it's not good for. But in this reference to location, because it's asking me about a location on where I can put this panel board, I went to locations. It absolutely is in the code, locations. Go figure, right? And so I'm looking at part 2. So I'm going to go to 240, and I'm going to go to part 2. And of course, I think Jay says you could find that under bathrooms as well, but I don't know that I would have intuitively looked under each one of these. But you could have. Use the answer. But I'm going to do 240 part 2, and let's see if that puts us anywhere where we need to be. Okay, part 2, location. Now bowl scan. I'm looking for location. Boom, boom, boom. And looking and see if I find where I'm going to be. Okay, Boom, boom. Location on premise, height, crap like that. And, location. Not located in bathrooms. Can't get any more bolder than that, right? It says it right in the bold heading, bathrooms. I didn't see garages. I didn't see hallways. I haven't seen kitchens anywhere, but I see bathrooms. So that's an example of using the answers while you're scanning. And I use location, okay? There is something in location. It says part 2, Daniel. Under location in the index, it says overcurrent protection, okay? And it says part 2. And that's where we're at, part 2, okay? So location. So yes, not in bathrooms. So the answer to your question is bathrooms. There you go. 240.24e. Let's do one more, and then we'll end it on a high note with everybody getting a good one, okay? But it just goes to show you that the index is, how many of you now you know that location is in the index? That's why we do it. Now we know that the location is in the index. So again, any question that asks me about location might be a place that I go. Okay, that type of thing. All right, so let's answer this one. Disregard any exceptions, so no exceptions are going to come into play here. Incidentally, when you take an exam, they'll tell you up front, and be very aware of it, they'll tell you whether or not to consider exceptions or not. Okay, so make sure you read all the information before you take an exam, do all the practice quizzes, read everything. It'll ask you a question like, what color is the sky? Blue, yellow, pink, whatever. Make sure you read everything before you actually start your exam, because that calms you down. Okay, it helps you relax to read all those questions and answer them. Okay, especially in exam tests that are going to be very stressful for you. Just read everything up front. Okay, that would be your internet connection, Jay. So it says disregarding exceptions. When installing electrical metallic tubing, EMT, the run of tubing is required to be securely fastened at least every blank. 15 feet, 6 feet, 20 feet, or 10 feet? Give me an answer, Joe. And Nick, stop giving me meters. Never give me meters anymore. Always give me feet, inches, things like that, okay? Never use the other. Always use feet, inches, at least in my studying. Most exams are not going to give you, dude, Bill says 385. Nick, come on now. Give me what's in the code. I want the values that are in the code, okay? And that's important because a lot of people will submit on our fast track stuff, for example. It'll ask for a certain, it'll say the answer needs to be in feet, and they'll give it to me in inches, and the answer's wrong. Why? Because it asked for the question in feet, that type of thing. So the reason I say that, okay, the reason I say that, Nick, is because you gave me 120 inches. But none of the answers are 120 inches. It's 15 feet, 6 feet, 20 feet, or 10 feet. So the answer would be wrong. Even if it was equal in inches, it would still be wrong because the question's wanting the answer in feet. You with me? And that's important. I'm glad you kind of did that because it allows me to tell people, answer the question, okay? When you answer the question to an exam, give them the answer that they want. Right? Don't let your field experience come into play. Don't start letting it get you into what's called a mind meld thing where you're like, okay, but it could be this, it could be. No. Just answer what they give you, okay? I know you're playing, Nick. I'm all good. I love teasing. So it's all good. So where do we find this in the code? All right, so we're having what's called a securing requirement. And I usually tell people .30 is the section in all of the wiring methods for securing and supporting. So it's one of those things that you commit to memory. Always remember, if it's a securing, supporting question, .30, .30, .30, boom, 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 boom. You should remember that, okay? But if you didn't, you can go to the back and go to electrical metallic tubing. Okay, that's a pretty easy one to pick out the keyword. So let's kind of go to the back and look under electrical metallic tubing, and you should see something for securing and supporting. But let's go electrical metallic tubing in the code. Let's see here if I can find it. There it is. And you come down and you will see that securing and supporting is 314.23e. But most importantly, we know that 314 is boxes. So 358, which is what the article is, it would be .30, which is the securing and supporting. Okay, so then we'll go to 358.30, and under 358.30, we'll go that to the code to tie this all up. And I hope you all like my space background, like Space Odyssey, whatnot. So again, I wanted to mix it up a little bit tonight. So let's go down to 358. And you go down to .30 right here, securing and supporting. And it says, EMTs shall be securely fastened in place at intervals not to exceed 10 feet. There you go. 10 feet. 10 feet was a question. 3 meters was not one of the answers in the question. So we're going to answer this question. 10 feet. There you go. 358.30a. Okay, makes sense? All right. Oh, it was great. I always have an excellent time with you guys, teasing, joking, pointing. Hopefully you never get offended because I don't mean it. The code is tough enough. I just love needling you and playing with you. And at the end of the day, my goal is that you learn and that you learn something. And look at all the subscribers coming in. That's my goal. Hopefully you got something out of it. Now obviously I've been away for the last couple of weeks because of my mom's situation and all that kind of stuff. But the chats, the exam prep's going to change a little bit coming up in 2021. What I want you to do is there's going to be a video coming out about it on my channel, explaining what we're going to do with the exam prep coming up in 2021, so that nobody's confused at what we're going to do with it. It is actually going to be by invitation. And again, it's a little complicated, but we're going to do the very first one I do in 2021 is going to, I shouldn't say this is the last one. It's going to be open. So, but when you attend that very first one that we do in 2021, I'm going to have an announcement, and I'm going, and the only way that you're going to be able to get into future exam preps, live streams, unless you're a fast track student or one of our subscribers on our channel, and hopefully you think about subscribing to our exclusive content, you have to be invited to it. Otherwise, it's going to be closed for fast track students, for invitations, and for people that pay for the subscription. I like to think, at least I would hope, that the value that I bring is worth that small monthly donation. I prefer you do that than make donations to me directly through our site. I prefer you join the membership and make that commitment to donate. You don't have to, okay? But again, there's 3 different levels, and the middle level and higher are the ones that are going to get access to the live streams that we do forward. Now, that doesn't mean I'm going to stop things I'm doing, okay? Podcasts and the occasional video, and I'm heavy into a new series that we're going to be doing in 2021. So hopefully, where I critique, videos and things like that, but I'll still be doing my other stuff, like I've got plans to also finish doing kitchens and explaining all the circuits in a kitchen, other areas of the house, commercial. I've got big plans. I don't know where I'm going to get the time. My wife is the one that's going to suffer the most, to be honest with you. So I'm just thankful that I can do all this. And again, y'all make it possible. So again, I appreciate all of you. So with that said, hopefully you got something out of tonight's presentation. We went 3 hours. So again, watch it over, pause it. But again, remember what I say. When you're studying, take your questions and take your time. Dissect them. You don't have to worry about speed until you get to the last 2 weeks or so for your exam. Then you need to get a timer. And then you time yourself answering the questions. Until then, I prefer you spend the time dissecting a question so that you learn what's in the index and what's not in the index, right? That's the goal. All right? All right, guys. I appreciate every one of you. Till next time, stay safe. God bless. And again, you all mean the world to me, and I thank you for taking the time out of your day to come to work with me. And hopefully I teach you something. If I taught you something, then there you go. Again, it means a lot. Till next time, folks, stay safe. God bless.